I am Anil Kumar. Welcome to my YouTube channel, the website Global Math Institute, and the WhatsApp group Free Math Solution. I am sharing with you a brilliant question from our WhatsApp group. The WhatsApp group is extremely active. Immediate solutions are coming from many of our professionals, and students are posting brilliant questions. Here is one of the best questions of the day where we want to figure out how many positive integer values of n will n to the power of 4 minus 3n square plus 9 be a prime number? So that is the question for you. You can always pause the video, answer the question, and then look into my suggestions. The solution of this question was provided by Mr. Narad, and I'm going to share with you the same solution. I am Anil Kumar. Welcome to my YouTube channel, the website Global Math Institute, and the free Math Solutions WhatsApp group. The WhatsApp group is extremely active. Many professionals have joined, and students from all over the world now are members of our WhatsApp group. They are posting brilliant questions and also providing excellent solutions. Here is an example. The question here is, for how many positive integer values of n will n to the power of 4 minus 3n square plus 9 be a prime number? Four options are given to you. The solution was provided by Mr. Narad. I'm going to kind of explain the same solution here. So let's look into the quartic equation which we have, which is n to the power of 4 minus 3n squared plus 9. We are looking for prime numbers, right? So when we are looking for prime numbers, the idea here is to factor. So our approach here is to factor, and then we could have factor as plus or minus 1, one of the factors. The other number should be a prime number, right? So the other number will give us a prime number. So that is the strategy. But the idea is, how do we factor a quartic equation? So that could be a new thing for many students. It is kind of a challenging question. So we have a quartic equation to factor. Now here is a neat way of doing it. We'll kind of do completing the squares. So as you can observe, we have n to the power of 4, which is a perfect square. 9 is also a perfect square. So in the center, we want 6, 2 times 3n square. Correct? 6n square. So we'll write this as equal to n to the power of 4 minus 3n square plus 9. And we're going to add to this the term 9n square and also subtract 9n square. Why did we do so? Well, to make these terms as a perfect square, as you will see just now. So we could rearrange and then write this as n to the power of 4. Combining these two, we get plus 6n square plus 9, and here we have minus 9n square. Correct? So what we did was we combined the like terms, which is these two terms. So when you combine these, you get 6n squared, and you also make a perfect square. So this is kind of completing the squares method, right? So that is how we are going to do it. Now actually we can write this as a perfect square, which is n squared plus 3 whole square, and here we have 9n squared. Now this can be written as n squared plus 3 plus 3n times n squared plus 3 minus 3n. Perfect. So that is how we could factor it. So let me write it in proper order, which is, always we should write the order from increasing to decreasing powers. So that is how we'll write it. So now we have a factored form. So it is much simpler now how to find number of values of n. We want n which should belong to integers, right? And that to positive integers, and that is where n is greater than 0. Clear? So those are what we are looking for. So let's rewrite this and continue with our solution. So we have the factor which is, let's rewrite. So n to the power of 4 minus 3n square plus 9. We have already written this as n square plus 3n plus 3 times n square minus 3n plus 3, right? Now to get the factors, what we will do here is we'll equate each to plus and minus 1 and see what works. Correct? So let's begin with the first set, which is for us n squared plus 3n plus 3. Let's equate it to plus 1, and also n squared plus 3n plus 3 equal to minus 1. So in this page, we will solve for these two equations and see if we have a solution. Now that gives you n squared plus 3n plus 3 minus 1 equals to 0, n squared plus 3n plus 2 equals to 0, and 2 times 1 is 3, so we get n plus 2 times n plus 1 equals to 0, and that gives you n equals to minus 2 and n equals to minus 1. So that we don't want. And here we get n squared plus 3n plus 3 plus 1 equals to 0. That gives you n squared plus 3n plus 4 equals to 0. And we are looking for, remember, the value of n. N is, for us, n belongs to integers, and we want n to be greater than 0. So here we have, it is not factorable. And these are also not valid solutions. Correct? So now, on the next page, we'll look into the factors of the second factor. Okay, so let's move on and see what happens. So we already have n to the power of 4 minus 3n squared plus 9 as n squared plus 3n plus 3 times n squared minus 3n plus 3. And now on this page, we'll analyze the second factor. So from here we get two equations. One of them is n squared minus 3n plus 3 equals to plus 1. The other one is n squared minus 3n plus 3 equals to minus 1. So we get here n squared minus 3n plus 3 minus 1 equals to 0. N squared minus 3n plus 2 equals to 0, which gives us 2 times 1. Both could be negative, so n minus 2 times n minus 1 equals to 0. And that gives you two solutions. One is n equals to 2, the other one is n equals to 1. Correct? Let's look into the next one, which is n squared minus 3n plus 3 plus 1 equals to 0. N squared minus 3n plus 4 equals to 0. 4 times 1, but we need a positive product, so not factorable, right? So no solution. No solution for n greater than 0, correct? Where n belongs to integers. So in this case, we have two solutions. And now, let us check if that results into prime numbers or not. So for that, we are going to substitute these values in the first factor and see whether that is a prime number or not. So n equals to 1 and 2. will be substituted into the first factor. So let's rewrite our expression, which is n to the power of 4 minus 3n squared plus 9 equals to n squared plus 3n plus 3 times n squared minus 3n plus 3. And here we got two values of n, 1 and 2. So let's try them out. So now we'll substitute these values in the first factor, so which is n squared plus 3n plus 3. So if I write n equals to 1, I get 1 plus 3, which is 7. And that works for us, correct? So that is perfectly fine. Now the second value is n equals to 2. So we get 2 squared plus 3 times 2 plus 3, which is 4 plus 6 plus 3, which is 13. And that also works for us. So we have two valid solutions, correct? So we can write down our answer now, which is n equals to 1 or 2. So we have two values. So option A is the correct option, correct? So that is how you are going to solve this particular question. I hope the steps are absolutely clear. Now let's look into these steps. We were actually provided with a quadratic equation, and this is very difficult to factor. So one of the challenge was to factor the quadratic polynomial, which is kind of difficult. So here we approach was to kind of complete the squares. And we did it by adding and subtracting 9n squared. Do you see that? So that was the key in factoring. And once we factored, in that case, we found the values for n, which could result into plus or minus 1. Substituting those values, we checked the result and verified that two values work for us. And those two values are 1 and 2, which is a part of our solution. And therefore, option A is the correct option. So I hope that makes sense. Feel free to join our group. I'm providing you with a link if you really want to post some good questions and provide solutions. Thanks for your time and all the best.